Hi, welcome to this video. Today's video we are going to give a general definition of the limit. Let's pick up f of x equal L as a value limit when x is approaching to the point A. Okay, let's go to the graph and take a look. You see the graph, this function is increasing and continue at all points. In particular, we are picking up the point A, and then we calculate the limit at the point A. Exactly. Okay, before we calculating the limit, you have to have an interval which is minus delta plus a on the left hand side of point A. On the right hand side you have a plus delta as an interval. Okay, when you calculate the limit at the point A, let's put the projection. So when you go to the A, let's take the maximum number of A, which is a plus delta. It goes to all the way down to the function, and then make the projection on y axis. You see L plus epsilon is a maximum number this limit can take. Okay, let's go to the left hand side of the point A, which is minus delta plus a. Let's put a projection on this function. As you see it here, you will see the limit value, which is L minus epsilon as a minimum number this limit can take. Okay, in particular, when you calculate the limit A, it goes right away to the limit L. So our limit is intersection of two regions, which is which has the red color, the other one has the blue color. When they make intersection, so that's the limit. That's our limit. So our limit is intersection of both regions. Okay, let's go to the definition of the limit and prove this theorem by using an example. Okay, the limit of f of x when x approaching A equal L as a value of limit for all epsilon greater than 0, the absolute value of f of x minus L as a limit is always strictly inferior than epsilon. So it exists delta strictly superior than 0. So absolute value of x minus A is strictly inferior than delta. Let's pick up f of x equal x squared as an example and calculate the limit at the point 0. Okay, so the limit at the point 0 when x approaches to 0, x squared equals 0. So let's use in the definition of the limit for all epsilon greater than 0. So f of x, which is x squared minus 0, strictly inferior than epsilon. Okay, so that's mean x squared, absolute value square, is inferior than epsilon, which is absolute value of x is strictly inferior than square root of epsilon. All right, let's go to second inequality for as a part of definition, which is it exists delta strictly superior than 0. So x, absolute value of x minus a, which is 0, is strictly inferior than delta. Okay, so x strictly inferior than epsilon. Look at here, we assume absolute value of square epsilon equal delta. Okay, so because we have both inequalities are going the same way, so the first inequality, which is x, absolute value of x strictly inferior than square root of epsilon. The second inequality with x, absolute value of x strictly inferior than delta, which is we can put, in this case we put square root of epsilon equal delta. Okay, this is the proof we proven by using this example. We proved this theorem, the first. Let's move on to the next example and the next function. Okay, let's make the difference between the first function and second function. The first function is a continuous function increasing. The second function, in particular, the at point A, this function is continue okay, and has the limit and has a finite limit, okay, which is L. The second example, we have at the point A, this function is increasing as well from the beginning with the negative numbers, and then keep going up, is increasing, but is not continue at point 0. On the right hand side of this function, the function keep coming down, is decreasing, and until you get to the 0 as a infinity, okay, to the it going to 0, okay. At the point 0 is not continue at point 0 from both sides, from left hand side and the right hand side. As we did before, we take the interval minus delta plus a on the left hand side of 0, which is a, and on the right hand side we put a plus delta as an interval. So our limit is located between this interval, it is this distance as a distance, okay. So it gives you the image of m as a minimum number can take, because if you take the projection of this a plus delta, it gives you m as a limit. If you take the negative, if you take the on the left hand side of a or 0, which is minus delta plus a, which is n, right? But as you are approaching to a, and your limit is growing up and then until you become infinity. That's what happened here. So if you take two first points and you make a projection, the next limit, you will be the number which is greater than n. And then if you take the second limit, and as the number is greater than the first number where we took on axis, or x-axis, is going its limit is going greater than the second limit, and so on, okay, until you get the point A. When you get the point A, your limit is going towards infinity, okay, as you see here. Let's practice. Let's go to the definition first of the limit of x when x approach A from the right hand side. Let's do the right hand side first. For all epsilon greater than 0, the absolute value of f of x minus L strictly inferior than epsilon, as we are using the interval on the right hand side, which we have here. So this interval has two parts. The left hand side when they have negative delta, on the right hand side when you have a positive delta, okay. That's what happened here. We are using the right hand side of interval. Let's go to the left hand side of interval, which is limit of f of x equal L as a limit value when x is approaching A from the left hand side. For all epsilon greater than 0, the absolute value f of x minus L as a limit is strictly inferior than epsilon, okay. So let's take the left hand side interval, which is minus delta strictly inferior than x minus a, which is a minus delta strictly inferior than x. Let's take this example. This example is the same, this function f of x equal 1 over x squared. So let's take the limit of f of x when x approach the a or 0 from the right hand side, as the example show on the above, okay. So let's calculate it. The limit of 1 over x squared when x is approaching 0 from right hand side, it gives you infinity. When x approaching the limit from the negative from the left hand side, which is the limit of 1x squared when x approaching the number 0 on the left hand side, okay, it will be the same thing, because squared by have square 1 over 0 minus square, it gives you plus infinity as well, as you see in this example. If you are approaching the a from the right hand side, your limit goes to the infinity. If you are approaching the a from the left hand side, the limit goes to the infinity as well. So let's go to the third and final example. The final example, the limit of f of x when x approaching plus infinity, it gives you the L as a limit for all epsilons greater than 0. the absolute value of x minus L as a limit strictly inferior than epsilon. It exists m strictly superior than 0 x, but here x has to have is always greater than m, as you see here x is greater than m. Okay, so this is different example. A limit of x equal L on the left hand side when x approaching minus infinity. Okay, for epsilon superior than 0 f of x minus L strictly inferior than epsilon. It exists n inferior than 0, x is strictly inferior than n, right? So let's take this example, the same example, but this time we are not using the x goes x approaching a. Now the x approaching infinity. That's the difference now. So the limit of f of x when x approaching from the right hand side plus infinity. What is infinity? This x, it goes all the way down to infinity. What's our function limit give us? As you go in more, as you see here, as you go in the right hand side more in the numbers of x's, you go more, and then your limit is going towards 0. You see, towards 0. So if you're replacing 1 over plus infinity, which is 0. Okay. Same thing for the limits when f of x is approaching minus infinity on the left hand side. As you the numbers, negative numbers going towards the end to the negative direction, so your function limit is become smaller until you get 0 as well. Okay, because if you plug in here 1 over minus infinity square, which is 0. So finally we finish this session. Okay, thank you. I see you in next video. Bye.